Nevada, we know we have a lot of solar energy resource here.
These solar installations need water, but they're out in these remote locations, and getting water to them is sometimes difficult. So if you can reduce the amount of water that you need out there, we can put them in different locations a little bit easier. So there's a particular component in these solar installations that uses a majority of the water, and so we're trying to target that and eliminate it essentially by substituting water cooling for air cooling. In a power generation cycle, there's 4 different components. There's the heating portion or boiler, there's the turbine where you get your power out, and then once your steam goes through the turbine, you need it back as water so you can boil it off again, and so the cooling component accomplishes that task. In a typical system, you have an A-frame configuration. So you have these inclined tubes where the steam flows through, and you blow air over the outside of it to cool it off. We also have a 30-foot tower that can measure the steam output of an actual tube itself in different tube configurations, and so we can look at how it would look in a simulated side, but we could also measure it directly. We're designing these towers to be a little bit more efficient so that way they can be smaller and cheaper.
We like to attract the industry people, company come to Las Vegas, come to Nevada State, and then we can use what we have learned from this project and to help them to build up the solar power the system.
We definitely want to make things like solar more applicable here in Nevada.
This overview project is saving the water cost. If we can reduce the quantity of the water being consumed by the power plant, that's the big success.